So my question was from chapter 4, and it was 52. You are target shooting using a toy gun that fires a small ball at the speed of 15 meters per second. When a gun is fired at the angle of 30 degrees above horizontal, the ball hits the bullseye of a target at the same height as the gun. When the distance is halved, at what angle must you aim the gun to hit the bullseye in a new position? So I started off by drawing a diagram because that always helps me. So you know that your motion is of projectile motion. So you know that your initial velocity is 15 meters per second, and for that, your angle is 30, and that hits it perfectly. So we're going to call that length between where the gun is shot and where the target is R. That's your range of motion. And what we're going to try to find is half of R. So R known, again, we know that for R, you have 30 degrees and your initial velocity is 15 meters per second, but we don't know R. And then once we find R, we don't know R divided by 2, and then we need to find the angle for half of this range of motion. So that's kind of the way we're going to do it. This is an important equation that we're going to use, and we have all the things that we need for it. We have the initial velocity, we have the angle, and we know G is 9.8, and that's for the range of motion of this problem. And then we're going to just divide it by 2 and then find the angle. So when we start this problem, we can just plug in. So first we're going to solve for R. We're just going to plug in what we know. Our initial velocity is 15 meters per second, and our angle is 30 degrees. So we're going to multiply it by 2, and our G is negative 9.8 meters per second squared. So once we have that, we can simplify. And I could simplify this more, but you'll see later that we're going to cross some things out. So what we really need to do now is, once we have found R, is find R over 2. So you can say that R over 2 equals, and then we just go back to this equation up here, and we solve the same things. So it's going to be the same initial velocity, but now we don't know what theta is, so we're just going to leave that there, and that's what we're going to be solving for. And acceleration due to gravity is obviously the same. So now, since we have solved for R here, we can just take this and plug it into R and then solve for theta. We're going to have a big equation, lots of things are going to cancel out, you'll see. So and that's R, so we need to divide that all by 2, and this will cancel out, that will cancel out, and what we're left with is 1/2 sine 60 equals sine 2 theta. And once we have this, we can go to our unit circle, and we can say, because we have sine of 60, so what you do is you go to 60 degrees, which is right here, and you see that cosine is the x value and sine is this, so this is what sine of 60 degrees is, radical 3 over 2. So going back to here, we then have 1/2, and we can substitute radical 3 over 2 equals sine 2 theta. And this will simplify to radical 3 over 4 equals sine 2 theta. And then what we need to try to do is get this theta. It's inside of the sine, so we need to get it out. And the way to do that is you use arc sine, or sine to the -1. So you take out the 2 theta, so you have 2 theta equals, just draw an arrow, 2 theta equals sine to the -1, or arc sine radical 3/4. And since we did it one way, we also have to do pi minus that, so because of the unit circle over there, we also have 2 theta equals pi minus sine to the -1 radical 3/4. And that's going to give you 2 different answers. It gives you 2 theta equals 25.66 degrees and 154.34 degrees. And I just got those by plugging these equations separately straight into my calculator. And then we divide everything by 2. And the angles we get 2 different ones, 12.8 degrees and 77.17 degrees. And if you think about it, the initial one was 30, and we're doing half of the distance, so we know that this is going to be probably less of an angle, right, if you think about it. So 77, an angle that's greater doesn't make any sense, so this is going to be our answer, 12.8 degrees. So just to wrap things up, to get to half of the range of the motion and to figure out what the theta was for that, we had to use this equation to find r. We divide it by 2 and find r over 2, and then solve for theta using some trigonometry. And we found that the angle for half of the range of motion would be 12.8 degrees to hit the target.